Which one of the following is the correct regarding an ionic compound MX? High value of lattice energy of MX ionic crystal. This is true. Electronegative difference between them should be high and not small. Okay. If this is small, then it is covalent compound. So this is wrong option. High ionization energy, no. Okay. If it is high ionization energy, then that means it will have lesser tendency to form ionic compounds. So this is also wrong. And the electron affinity, obviously it has to be high for the anion. So this is also wrong. So over here, correct option is A. Which one of the following represents correct order of lattice energy of oxides among the alkali metals? So we know from the equation, which is obviously what we will say. F, the force of attraction, is directly proportional to Q1, Q2 by R square. Okay, over here R square or R is the internuclear distance. Okay. Even if you write the lattice energy expression, which is obviously U, okay, that is Z plus Z minus E square A N A, which is obviously Avogadro number, R 1 minus N 1 minus 1 by N, obviously. So here we can say Z is the Z plus is the charge of cation, Z minus is the charge of anion, E square is the electron, A is the Madelung constant, Na is the Avogadro number, and R is the obviously again Newton nuclear distance. So U is basically inversely proportional to R. That is what I'm trying to say. Okay. So this is basically what? This is basically radius of the cation plus radius of the anion. Okay. So now if this increases, if you go down the group, we can see the cation radius will increase. Okay, this will go on increasing. So this will increase and that should decrease. So our answer should be what? Beryllium oxide should be more than that of magnesium oxide, which should be more than calcium oxide, which is more than strontium oxide, and which should be more than the barium oxide. Option D is the correct one. According to Fajans rule, which one of the following conditions is necessary to form a covalent bond? Obviously, cation size should be small and anion size should be large for covalency character. Okay. Next question 22. Which one of the following represents the correct bond order among the given nitrogen species? So for that we have to draw the molecular orbital diagram. So for that what we should do over here is say this is 1s for both the nitrogen atoms. So this is nitrogen atom, that is nitrogen atom. This is the MO of N2. These are the atomic orbitals. So then we have the 2s and then we have the 3p orbitals, sorry 2p orbitals. So this is 2p, this is 2s, this is also 2s. Both the 1s will combine with each other and form the anti-bonding and bonding orbitals. So below is bonding orbitals and above is anti-bonding orbital. Similarly for 2s, this is the bonding and that should be the anti-bonding over here. Okay. Then we have to draw the orbitals formed by the combination of the p orbitals. Okay. So for that, what we do over here is two such. Then we have these are the pi bonds. Then there will be two such pi bonding levels, and this is the sigma bonding level. Okay, so these are all bonding in nature. Then we have the anti-bonding pi orbitals, and this is the anti-bonding sigma orbital coming from the overlap of the 2p orbitals. So there are 14 electrons that needs to be included. So 1, 2, 3, 4, 5, 6 and 7. Similarly 1, 2, 3, 4, 5, 6 and 7. So now if you fill up 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. So as we can see, this is the bonding zone. This is the one. Okay, and the rest will cancel with each other. So we will say bond order of N2, bond order, sorry, bond order. So this is say N2, we will say it is 6 minus 0 by 2, and that is going to be 3, right? For N2 minus, it is what? So it should fill up this anti-bonding orbital over here. This is now becomes N2 minus. Electron should be added over here. Okay, so that means 6 minus 1 by 2, and that should be 2.5. For N2, 2 minus means what? Another electron added over here in the antibonding. So 6 minus 2 by 2, and that should be 2. So obviously over here when they are saying bond order, so we will say N2 has more than that of N2 minus than that of N2 2 minus. Answer over here is going to be C, the correct answer. Now if you want to draw the electronic configuration of O2 2 minus. Question number 23, which one of the following is the correct electronic configuration of O2 2 minus? So over here what we do, we simply again draw the molecular orbital diagram. So this is a 1s, again here we have the 2s, again we have the 2p. So let us just combine like that, like that. Then we have this one, antibonding and antibonding. So this is 2p, 2p, 2s, 2s, 1s, 1s. So only difference with the N2 if you see is this level and that level. So there is a reversal there. So over here, always remember that the sigma bonding orbitals, MO are G-red. Sigma antibonding, MO are un-G-red. That means U, and G-red means G. And the reverse works for the pi bonding orbitals. So pi bonding orbitals, MO, we will say are un-G-red, and pi star bonding MO are G-red. So here pi star means this level. Okay, so this is our pi star. So I will say this is 1 pi G. This is pi star bonding, so I will call this as 1 pi U. Okay, and then we have the 2 sigma G, and this is the 1 sigma U, and that is the 1 sigma G. So we have to fill up now 16 electrons. Let's do that. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Now for that is for O2, right? But for O2, 2 minus means you had 2 more electrons like that. So now if you write the electronic configuration, it will be what? 1 sigma G2, 1 sigma U2, 2 sigma G2, 1 pi U4, 1 pi G4. So the correct option over here is going to be option number A.